Hi guys, in this video you are gonna draw this image with me. If you press a mouse button, so a new trees are drawn randomly. Here, random means random tree size and random tree shape. So let's think about that. How can you make this one? First of all, I think you have to make a tree, and you have to give a randomness to the tree, random shape, random height, kind of. So for me, I made this picture with recursion. So let's see this one. So this is processing.org. If you go to the page for the recursion, you can make this kind of pictures. This technique is called recursion or recursive function. So what is the recursion? Oh, then what is the recursive function? Then let's go to the google.com and let's type in recursion image drawing, kind of. So if you go to the image tab, you can see so many pictures, right? I'm sure all of these images were drawn recursion or recursive function. Tree and other shapes, circles. Yeah. Can you tell what is the characteristic of the images? That's kind of recursive. So for example, if you wanna this one, you need to draw the square and circle, right? And you have to do all the job with the difference with size, right? So let's go to the tree too. If you want to draw to this tree, you have to draw one line and two lines and two lines, right? That's kind of the characteristic of the problem, which you can apply recursion or recursive function technique to draw that. Let's come back to the processing. So before try to draw this kind of complex image, you have to know what is the recursion and what is the recursive function and how to use that. So let's begin. So in this code, we want to make a function to return the sum from 1 to n. So let's declare the function. So this function will return integer data type. So let's name this function itersum, which means iterative sum, which means to get the sum, we will use the iterative for loop. And it has one parameters. So if you give a parameter number n, it will return all the sum from 1 to n. So let's declare the variable first for initialization, and for int I equal 0, I is less than or equal to n, because we want the sum from 1 to n. No, so this I should be 1 and I plus plus. And in the for body, we are gonna get the sum of I. So after finishing this for loop, the sum variable has the sum, final sum. So we are gonna return the variable sum. And we need to call this one, right? So let's go to void setup. And let's call the itersum. Gives the number 10 to the parameter. And let's print these things using the print line function. So let's turn on the console and let's run it. So here we got the 55, right? This is sum from 1 to 10. So this is iterative function to get the sum. That's the first way to get the sum. But in this video, we want to learn how to get same result with the recursive way. So let's make one more function. So int recursum, int overall shape is same, right? So to get the sum, what do you have to do? Let's think about this. So we want to try to get the sum from 1 to 10, right? plus 9 plus 10. So we want to try to get this one. So the sum from 1 to 10 is equal to the sum from 1 to 9 plus 10, right? And at the same, so let's keep going this way. So the sum from 1 to 9 is equal to the sum from 1 to 8 plus 9. Let's keep going. So the sum from 1 to 8 is equal to the sum from 1 to 7 plus 8. So let's write down in a kind of pseudo coding style. So the sum 10, which means the sum from 1 to 10 is equal to 10 plus sum 9, right? And sum of 9 is equal to 9 plus sum 8. If you keep going, maybe the sum 10 will be like this. Like this. The sum 10 will be, if you keep going, it'll be 0 plus sum 1, right? So what is the sum of 1? Sum of 1 is the sum from 1 to 1, right? That's the 1. So you don't need to keep going from now on. So that's the end of function call. Can you think about that? So let's think about this one first. So the sum of 10 is function call to get the sum from 1 to 10. This problem was divided into smaller one. So sum of 10 equal 10 plus sum of 9. So let's remember these things and let's convert that things into code. So this one. So recursive sum of n. So the recursive sum of n, which means the sum from 1 to 10 is what? Is equal to n plus recall sum 9, right? Let's write down some kind of comment. So recur n is equal to n plus recall sum 9, right? So if you call recursion n, it should be return n plus recursion. But if you keep going, the parameter will be sometime, finally, we get to the number 1. Then it should stop to recall, stop the recursive call, right? So we have to give one conditional statement at the beginning of function. So if n equal n, so which means the parameter is n, then we have to return just number 1, right? So if n is not equal to n, which means n is larger than n1, then it should return n plus recursive sum. So this is recursive function to get the sum from 1 to n. So let's call this one. So we need to change this one. And let's print line one more. Recursion. Let's call this one. So let's see the console. It doesn't work? Oh, this is my mistake. So n plus n minus 1, right? So the recursive sum n is same to n plus recursive sum n minus 1, right? So let's change this one to and run it. So iterative call, function call gives us 55. Recursive first function call, same. So this function is called recursion or recursive function. What it means? So this recursive function, recursive sum function, calls itself, right, with different parameters. So the sum from 1 to 10 is same to 1 to 9 plus number 10, right? So this kind of function is called recursive function. But the most important thing is the kind of basis condition. So this function if statement is called basis condition. or terminating condition. So let's think what if you delete this one, what will happen? Control slash, yeah, right? So if you delete this if statement, which means the basic condition or terminating condition, what will happen? Let's run it. So the first function call, iterate function call, gives us a result, but the second recursive sum gives some error. Can you see the error message? So stack overflow error means that you have a bug that's causing a function to be called recursively. So the iterate recursive sum function called with the number 10 will call number 9 for the parameter, and 8, 7, 6, 5, 4, 3, 2, 1, 0, and it will keep going. It will keep going, -1, -2 to infinite numbers of calls will be happen. So whenever the function is called, the stack is used there. So it's infinite call, right? So stack has been overflowed. So you have to keep this in mind. When you use the function recursive function call, you have to make a basis condition clearly. So because this is basis condition, or also this is terminating condition too. That's really important. Let's see another example for the recursive function. So we wanna try to print out all the numbers from n to 0 in a decreasing order. So which means if you give a number 10, it will print out the number 10, 9, 8 to 0, right? So let's do this one. So this function, which has the name iter print, will print out the number n with an n. So it will print out the number from n to 0 in decreasing order, right? So let's make set function to try to call this one. What do it do? So I'm gonna call iter print function with number 10. So let's run. Let's look at the console. So the number was print from 10 and to the 0, right? This is iterate way to print out the numbers. So we want to make the recursive print function. So let's make the print recur print, and it has the parameter n, same. So we have to make the recursive function. So what do you have to do? So if you give number 1, we will, what do you have to do? Print to n, right? And then we will call itself with n-1, right? So if you call the function with parameter n, it will print the number n, and it will call recur print function with n-1 for the parameters. So what I told you, you have to make a basis condition and terminating condition. So if n is less than 0, which means if n is minus, negative, then you have to finish the function call with return. So this return has no value, right? You just stop the function call. And so if you, this is the same. So if you else, so this is a better way. So if n is negative, just stop the recursive call. Else, you have to print out the number and then call the function itself. So this is how to print out all the numbers with recursive functions. So let's call the recall print function with the same parameter. So let's make iteration print line, yeah, and print line recursion. So I think that's it. So let's run. So can you see? So at first the iteration function was done to print the numbers, and recursive function print number 10 to 0. So can you guess how to use the recursive function? So you have to make the problem with smaller problem, and then you have to make the basis condition too. That's the most important thing. Let's see another example. So do you know what is the factorial? So let's see. So we use the exclamation mark. So n factorial is the multiplication of n from n to 1. So which means 4 factorial is 4 times 3 times 2 times 1, which is 24. So n factorial is n times n minus 1 times n 1. So the times of all the numbers from n to 1. So this is an iterative way to explain the factorial. But let's think about this way. So n factorial is the n times n minus factorial. So we can define the factorial problems in recursive ways. Then, which means we can make this factorial. We can get the factorial with the recursive function too. So let's do this. Let's get the factorials with a loop and recursive way too. So let's make the iterative way at first. So int factorial int n. So we'll get the factorial with for loop, right? So let's declare int variable result equal number 1. You have to initialize the result variable with number 1. And for int I equal 1 and I is less than or equal to n and I plus plus. So we'll multiply from number 1 to n to the result variable. Result equal result times I. So that's it. So we need to return the result variable, right? Result, right? So that's the iterative function to get the factorial. So let's call that function. So print factorial number 4. So this will print 1 times 2 times 3 times 4. Is that 24? Yeah, 24, right? And then we have to make the recursive function too. So let's make the recursive version for the factorial. So int n. So how to get this one? So we need to return n times recall factorial. Is this right? Factorial recur, right? And with a parameter n minus 1. That's the recursive way to define the factorial. And you have to give the terminating condition, right? If n is less than or equal to number 1, it should return what? Just number 1. So if you give factorial 4, this will call factorial 3 and factorial 2 and factorial 1. If the parameter is number 1, then this condition is true. So it will return number 1 without calling the factorial function recursively. That's the terminating condition. That's the basis condition. So let's call the recursive function called print line recall factorial, right? And number 4. There is no there's no errors here, and let's run it. Let's see the right. So iteration call gives us 24. Recursive function also gives this function call too. Let's use print line function to change the line when you print out the numbers. So let's compare this recursive function and the iterative function. Which one do you think is better? So in the style, in the code shape, recursive function is much more compact and intuitive, right? But the thing is, generally speaking, recursive function is slower than iterative function, because whenever you call some function, in the system has to manage the stack. Do you know what is this? What is the stack? Anyway, so whenever you call the function, the system has to make or delete the function and delete the stack. So this is so time consuming, which means the function call is time consuming. So usually recursive function is slower, but this is intuitive and logical. This is more fancier. This is the end of the introduction to the factorial or some recursive function. So in the next video, let's draw something with a recursive function. Bye.